Hello and welcome to this episode. Today we'll be continuing on from where we left off last time. Last time we programmed an ESP module so we could write BASIC to it and program it that way. BASIC is a language that has been around since the 60s and it's really easy for new people to programming to understand and get on with. The ESP module I'm using is cheap and has multiple IOs, so we can do lots of things with it. In the last episode we managed to turn on the LED light remotely. In this episode I want to be able to make the motor run forward and reverse, and also have our steering going left and right. So let's get on with it. So I'll just introduce you to my jig here. I've got the ESP unit obviously. I've got 3 LEDs. This one is just for power, this one will be our motor control, and this one we'll be using that later on. What I've learnt with this unit is most important thing is to have a dedicated power supply. I've spent countless hours trying to fault find this without a dedicated supply. I used one from a Arduino and it was bizarre. It would work for hours and all of a sudden all sorts of weird things start happening, so a must is a dedicated supply. Also pull-ups on the reset pin, the chip enable and the GPIO0 as well for more reliable operation. So our first thing we want to do is, for the remote control, we want it to have it like a slider control, so you can slide the speed up and down with a pulse width modulation. So on the ESP basic website there's a few good examples, and this is the first one I found that worked nicely. So basically just cut and paste the code, went into run, it comes up with this slider bar, and whenever I set this slider bar and click on set level, it changes the load intensity, and we can just translate that to motor speed really, which is great. So the concept works, we can have variable speed. Problem with this is it'd be a bit tricky driving a RC car when you've got to move the value up and down and then hit a set level. So we need to alter things slightly so we can move the slider up and down and then have the speed adjust automatically without having to click on set level. Okay, so we reached a bit of a crossroads in our development now. In that last example, the whole screen was drawn by the ESP BASIC itself, so it wrote the scroller bar across the screen, which is fine. But another way you can do it, and it gets a bit confusing, is you could get the ESP BASIC to generate and write the whole page, or you can create an index file and save it on the unit and then just browse to that. Now the benefit of that is you can just write a web page in the traditional method with HTML, JavaScript, CSS and all that sort of carry on. If you run it within ESP BASIC, you've got to do sort of extra bits and pieces to get those pages to work, which makes it a little bit more complicated, and I think probably a little bit more overhead for the unit to process. So I think the best method would be to just ask the ESP unit to do something rather than generate all those pages at the same time. So ask it to go forward and reverse, left and right, rather than draw the whole page and listen to what's happening on the screen. So what I'll be doing is be creating a web page separately, but it does exist on the unit, and within that HTML and JavaScript sending commands to the ESP unit, so go forward, go back, go left, go right, and that's all it's got to do. It doesn't have to do anything else. It's acting a bit like an API. So let's get on with that. So on the ESP BASIC website, in the documentation and examples, there's a little bit of code here called message URL usage, and what this enables you to do is put in the URL of the ESP unit and then add variables or data after that for the unit to decode. So for I changed my code to this. So at the top here it just prints off a URL for me to go to because I've got terrible memory for those sorts of things. Message branch, so it's waiting for the URL to be posted. This is from the original code that I borrowed. My branch pin status, so it's waiting for the stat variable. Within there is the pin status, which is sent from the JavaScript. So in the JavaScript, this is the code. It's pulling the jQuery off the unit. It's got a dimmer, and the dimmer is when this event, when it has an input change, it sends the value of the range bar or slider to the URL for the ESP unit. So as I crank this bar up and down, the LED gets brighter and brighter. So it's all happening dynamically. One problem with that is, you can see it's going a bit freaky now. It's lost the plot. If we look at the what data's going down, it's just streaming data relentlessly. And this empty response usually means that the unit has crashed because it can't handle all the data going in. So if we move this now, you can see how much it's sending down. Every single step it sends down a figure. And these error responses, just the unit can't get back. If I move this fast enough, we'll actually just crash the thing altogether. So what we need to do is adjust the code slightly, leave it delayed, so it will wait until it's set the LED level and then replies back to another packet of information, so it's got time to process everything that's happening, and that's what we did next. So for the next attempt I didn't need to alter the basic code at all because it's doing essentially what I want it to do. It gets the data from the URL and then adjusts the light. I made changes in my JavaScript, so down here it's got a little bit of code that says wait until it's done and then print out on the screen the result. So if we pop in and run that, there's the lights going up and down, and if we look at the code, what's happening in the back end, we're getting this OK back. So the JavaScript is not sending any more information until it's got OK come back from the unit itself. So it's giving it time to receive the data, adjust the pulse width modulation, and then send back an OK. Now I'm ready for more data. So I can pretty much move this up and down as much as I please, and it won't freeze up. I don't get any more of these error reports, and it's keeping up pretty nicely. Okay, so that's brilliant. So it's all happening sort of dynamically. I can move this up and down and it immediately changes the state of the power going down to the LED. So the problem we have now is with most remote controls, it automatically goes back to center. So this one, for example, if I pull the trigger, it automatically goes backwards, back to the center, and also we've got backwards and forwards. This unit, at the moment, it's just got, you set it and then it stays there, which isn't entirely practical. So I need to change the code slightly on the JavaScript side so that it will automatically go back to center, but also have a negative value to go in reverse. I have altered the minimum value to minus 1024, maximum value to still 1024, but the default value is 0. And this bit of code here listens for the mouse being clicked up, or if you've got a mobile device, touch in, touch cancel, take your finger off the screen, it'll run this little snippet which will set the speed back to 0 straight away. So let's run that and just see what the result is. Okay, so we've got our dimmer now, it's set in the center. If we move it up, it springs back. So max, back to 0, negative value, back to 0. So that's pretty good. That's what we're after for the speed control. So I'm pretty happy with the way that's going. So the speed control I have has two inputs. One is for the speed of the motor, and the other input is for the direction. So I need to get this other LED to turn on or pin to go high when it goes in reverse. So I've altered the code again. So down here, if it gets a negative value, or less than 0, it will set their pin high. So let's try that. So that LED turns on whenever it goes in reverse. Which is perfect. So that's pretty much our motor control, essentially, as a proof of concept is working perfectly. Now we had to add steering. So this is where things get a bit more tricky. I need to be able to steer and accelerate and reverse all at the same time. So I don't want the unit to stop just because I'm steering, or the steering to stop just because I'm driving forward and backwards. So what I've done is down here I have a controller which is listening to all the buttons, listening for any changes in these buttons or in the slider, and if anything changes it'll grab the speed from the slider, and if the button is down it'll send a direction to the car. So basically the controller class encompasses everything within the control panel there. And so input, if it changes, mouse down or touch start, go to this routine and send the data to the unit. Also I've got it listening for when the mouse goes up or touch ends, then the steering should center. So if you lift your finger off the one left or right, the steering will go back to center again, otherwise you're stuck going in a circle. And it also grabs the speed. We've also got the trigger for taking your finger off the slider, touch mouse up, touch end, it'll return the steering to center and stop the car. So up here I've added buttons, as you would have seen on the other page, left and right buttons, and the accelerator. In the code from the basic, I'm just waiting, it picks up the new variable, which is the direction. If it's left, turn left, change the IO pin 16 and 14 to high or low. There's not much point having pulse width modulation on a solenoid. It won't make any iota of difference. It wants full noise left or right, so there's no in between. And if it gets a center message, it just sends it both high, which makes the steering go straight. So we'll run this and we'll go to the toggle test, and I'll just like to welcome back the Hotwheels car that I did a teardown on a few episodes ago. It's looking a bit Frankensteinish now because it's all hooked up to our unit. This is just a LGBO speed controller, which is current within the specifications of this car, so I can cope with it. And if I run the speed control, you can hear the pulse width modulation starting, and you've got to get quite high, up to about 600, and halfway through to get any movement out of it. Forward, reverse, left, and it goes to the centre. When you take your finger off, right, but if we keep it left, we keep our finger down, it stays left until we take our finger off. So conceptually this all will work. So the steering is no longer hooked up to the main board of the original main board, and the motor clearly is disconnected as well. I can steer and I can run the motors, and I can do them both at the same time. So this code, it needs a bit of tidying up clearly. In the UI, what it looks like isn't particularly attractive. So in the next episode I'll be tidying up the UI so it looks a bit easier to look at and nicer to use, and we'll be building a board for the whole lot to sit in this little area here. So it's going to include the Wi-Fi unit and the driver board packed in there, which shouldn't be too much of a mission. In fact, you'll probably better set them on top of each other. So that's it for this episode. In the next episode we'll be designing and building the circuit board to put into the car, and then in a later episode we'll probably look at doing the UI on the app. But first and foremost I want to make sure I can get it into the car and working as a unit by itself. So we'll catch you next time.